All right. In this tutorial, we'll finish up our mouse Theremin interface. And just to review, what we've set up a way for the mouse to send a mapped value, or to use the mouse to derive a mapped value. In the case of our horizontal or x-axis, we're going to send a MIDI pitch. And in terms of the y-axis, we're going to send an amplitude between 0 and 1. Now, we, in the last tutorial, also set up our messaging system, our open sound control messaging setup. So now we have a little machine, a little bot that is ready to send OSC messages. And so this one, we're going to actually format those messages and send them out. So what we do here then is, we can comment that out. We're going to send out messages when our mouse is pressed. So if you'll recall from the processing basics tutorial on built-in functions, there's a built-in function or a method called mouse pressed. And that's its scope there in the curly brackets. So every time I press the mouse, it will run all the code in here. Another way of thinking of this is a scheduler. So you're going to schedule a block of code to be executed when you press the mouse button. That's another way of thinking of it. It's independent from the draw function. So let's go ahead and set up our first. So every time we press the mouse, basically we want to send 3 different messages. We want to send a trigger message, a pitch message, an amplitude message to SuperCollider. And if you remember the way our OSC defs were set up, basically it's looking for these messages. So in the case of pitch, it's looking for this message pitch. And when it receives this message pitch, it's going to set our mouse theremin to the pitch that comes in as the first argument. Okay, so we have to format a message that has the header or the OSC address pitch, and then has one additional argument, which is the actual pitch that we want it to change to. All right, so let's do that. And we won't want that to be happened each time we press the mouse. Okay, so in fact, here we have pitch and everything updating in draw, but why don't we do it here in mouse press? So it's not continuously updating, but it only updates when we press the mouse. So we're going to cut that out of there, and we're going to paste that in there. So every time I press the mouse, I'm going to update both my pitch and my amplitude, because remember, it's a global variable accessible from anywhere. And I'm going to update that global variable to be this mapped value and this amplitude. All right, and then the next thing I want to do is I want to send an OSC message. Okay, so first of all, I'm going to create a local variable, which is an OSC message. And it's like this, OSC message. That's the name of the variable, or the variable type, OSC message. And I'm going to just give it a name. I'll maybe call it pitch message, like that. Okay, and then I can declare it and initialize it all at once. And it's looking for a new OSC message. And it takes the argument of the address that you're sending it to, the OSC address, which in this case is pitch, because SuperCollider is expecting pitch. And remember, the / is just the syntax of OSC. So all messages have this / syntax. Okay, so we're going to create the message. Now we have a message pitch that has this address, OSC pitch. And then we're going to add some data to that thing. So we're going to say pitch message dot add, and then the item you want to add to it. Well, we're going to add the actual pitch here, which is a float. Okay. So again, going back to SuperCollider, our OSC def pitch is looking for this address. Once it sees this address, it's going to take in this message. And remember, message 1 The first message 0 will be, it's a bit redundant, but it'll be the repetition of this OSC address. And then message 1, or the second item, will be the data we send it. Will be the first bit of data we send. This pitch message, add pitch. All right. And the reason, just to review, the reason we do this as float is sometimes between programs it's not very clear. The data type that comes in is not explicitly declared. So we're just going to make sure that comes in as a float so that it doesn't screw up the thing it passes it to. Last step is to then send the message. So we'll say, we'll use our OSC machine, or OSC bot. So we just called OSC. And then we'll use the function send. Okay, and then it takes a few arguments. It takes what message we want to send, so that's called pitch message. Okay, that's this OSC message pitch message. And who do we want to send it to? We're going to send it to this net address, SC. Okay, so in this mouse press, in this from here to here, remember code is run in order, so we're going to first update the pitch. It's going to make this variable pitch equal to this mapped value. Somewhere the mouse X is going to be mapped between 0 and 800 to 47 and 73. It's going to update the amplitude, same thing. Then it's going to make an OSC message with the OSC address pitch/pitch. It's going to add a bit of data to that. And then it's going to send that to our super collider. All right, so let's go ahead and I'm going to alter this slightly just so you can see it come through. And I think this is running. Yeah, it's running, so it should change the pitch, but it won't make any sound just yet. We'll say msg.postLine, post-ln, and I have to just send this OSC def again, which I can do on the fly. So now when I run this, it will send, every time I click the mouse, it will send the updated pitch to my super collider. So let's, we have our sketch here. Let's get our super collider handy so we can see the print window. And we're just going to look here, right here in the post. And every time I click, it should be sending that message. Okay, so there you go, pitch, depending on where I am on the sketch. So from 47 all the way to 72, and you see it printing down there. Okay, so that works very nicely. All right, now we're going to do the same exact thing for the amplitude. So we'll go ahead and send an amplitude. And I'm just going to copy this, this code. It's very reusable. We'll call it an amp message. And we're going to send the address amp. Just make sure they harmonize. So I'm looking for amp here. And I'll make sure that one there says amp. And then just make sure since I changed the variable there, I have to make sure I'm adding the right amp message. And we're going to add amp. We're going to add this variable amp here. Okay, and again, to make sure we're sending the amp message. Okay, and the last one we want to do is this trigger, because it's not going to play unless we remember in our synthdef, we have this envelope that's being triggered by this trig. If the trigger argument receives a 0, it shuts it off, it releases the envelope. If it receives a 1, it attacks the envelope. Okay, it engages the attack phase. And then it's this ASR envelope, so sustains at that attack level, which in this case is just hard-coded to 1, until you release it. So we need actually 2 messages. So first one will be on mouse press. So when we press our mouse, we're going to attack our envelope. And we're just going to say trig message. And then we're going to say trig. Just double check that it's trig. Yeah, TRIG. And we're going to add, in this case, when we push the mouse, we want it to send a 1. We want to engage the envelope. So we'll send the 1. Make sure we update all our variable names. trig mesh, and then we're going to send it. Okay. And then what we want to do is we want it so that when we release the mouse, it sends a off to the trigger. It sends a trigger 0. Okay, so we're going to actually have to start another preset function here, and that's void mouse released. Another built-in function to processing that, just like mouse pressed, will run all the code in the curly brackets when you release your mouse. So I'm just going to copy this code because it'll be very close to that. We're going to send the OSC message when we release the mouse. Message trig, except this time it's going to be 0, and that releases the envelope. And then we're going to send the trig mess. We can say something like trig to message or trig off message, just to be, so we're not confusing it too much. Okay, so that should pretty much do it. I think this is primed and ready to go. So let me just run this sketch. And hopefully this works. Yep. So every time I push the mouse, it's going to change pitch. Higher pitch there, lower pitch there. When I release the mouse, it changes the envelope. And then higher up here is higher amplitude. That's close to 1. And down here is much softer. All right, well, fantastic. So our interface works. We're sending these messages to Super Collider, and our mouse theremin essentially works. So this will be the basis for developing more sort of performable instrument. It gives a nice introduction to interactive sound making using different programs. And so we'll be developing our interface. We'll be developing our instrument to make nicer sounds. And you can check out the section down at the end of the tutorial for some ideas for inspiration about sine wave music or people using theremins, actual theremins or digital theremins. I just added some links to various performances on YouTube. Great. So I think that works very well. And we'll use that in later lessons to develop it, make it richer. In fact, I think I made a little list of things. It would be nice to be able to have a slidey. Right now, if I gliss, there's no sort of glissando thing. And that's a big part of sort of theremin music, as you have that glissando. That's easy enough done, but we'll go through that together. And then, it'd be nice to be able to change amp while you have the mouse pressed. And that's just a matter of just changing, using a different function. In fact, if you want to look into it before, see if you can figure it out, it's probably using something called void mouse dragged. And that might be the deal. Let's see. You can also replace pitch range with variables. So might be nice to have a variable pitch range that you can change, perhaps maybe even on the fly, but at least you can make those variables and have that change, by changing those variables. Make a visual keyboard with pitch restriction. So for right now, I can play a bunch of microtones in between. But you can imagine making a virtual keyboard where if you hit a key, it's only going to play that one note, no matter if you hit to the left of the key or the right of the key. And that'll just involve some if statements and some restrictions there. And then you can also create little graphic things. So for example, if you make a virtual keyboard here, you can, every time you hit a key, you can have it light up or something like that. Lots of different things you can do, but we'll explore those things in future tutorials.